In this video, we'll be talking about scientific notation. Observe a pattern, see how to write a number in scientific notation. And first of all, what is scientific notation? That is just a way of writing any number. So scientific notation is a way of writing large and small number using powers of 10. So the numbers don't have to be too large or too small. Any number can be written in scientific notation, but it's important to use a power of 10 in the process. And it could look like this: a number multiplied by a power of 10. I'm going to show a few examples. What kind of number, what kind of power, how to write a scientific notation, and what it is, the actual number, and is a number between 1 and 10, but not 10 itself. Let's say between 1 and 9. So the number is in between 1 and 9. So it can equal 1, 2, 3, 4, 5, 6, 7, 8, 9, but not 10. So a number between 1 and 9 included, but not 10. And the a is the exponent, which is an integer, can be positive, can be negative. And what we're going to explore is how a scientific notation actually using that number between 1 and 9 and a power of 10. So first we explored our powers of 10, and then we said that, let's say 10,000 is 1 times 10 to the 4th power. So 10 times 10 times 10 times 10, we have 10,000, 1, 2, 3, 4 zeros. If you multiply 10 4 times, you get 10,000. So let's see how that relates to a number that has thousands involved. So this number right here is 24,327. The significant number is 20,000. It's like the largest amount is the biggest significance. In other words, the first digit is telling you the largest amount. So here we have 20,000, then 24,000, and hundreds and tens and ones. But the largest amount, the biggest significance, is the 20,000. So that is the digit that is used in scientific notation, 2. And showing its significance will be the power of 10. So 2 times 10 to the 4th power is representing 20,000. How many? 24,327. But to write in the scientific notation, which has the n, the number between 1 and 9, 2. So the decimal goes after the first significant digit. After the decimal, all the remaining numbers, times 10 to the 4th power. So what does that mean? That means that if I multiply 2.4327 times 10 to the 4th power, I can multiply times 10 times 10 times 10 times 10 4 times, or I can multiply by 10,000. So we're going to multiply that by 10,000. 1, 2, 3, 4. 1 with 4 zeros. And that is my 24,327, which was the original number. So the number is the same, but just written in a different form. To write a number in the scientific notation, the number in standard form, using the first significant digit, place a decimal, and multiply by the power of 10, representing the amount. 20,000 will be 10 to the 4th power, which is 2 times 10 to the 4th. Let's see another example for the pattern. 1,000 is 10 to the 3rd. How many thousands we have here? We have 7,000. And that is the most significant number, 7,000. After that, we have 354, but the significance is in the largest amount, which is 7. So place the decimal after 7. 7,000 means 7 times 10 to the 3rd power. So the decimal is the number between 1 and 9, and then multiplied by 1,000 will be 7,000. In scientific notation, that will be 7.354 times 1,000. Let's see if we have that same number. So 7.354 multiplied by 10 times 10 times 10, which is 1,000. And here's the original number. Let's see another example. My next number is 482. 400 is 4 times 100. 100 is 10 to the second power. So to write the number 482 in scientific notation, we put the decimal after the first significant digit, which is 4, and multiply it by 100, which is 10 to the second power. So 4 is a number between 1 and 9 times the power of 10, which represents 100. 400. 4 times 100 is 400. 482 to be exact, but in scientific notation, the significance is the digit between 1 and 9 multiplied by the power of 10. Another example, 89. 89 is 8 times 10 to be 80. How much is 80? 80 is 10 multiplied by 8. So the first significant digit is 8. That is 8 times 10 to the first power. If I multiply 8.9 times 10 to the first power, I get 89. So let's see that. 8.9 times 10, that's 89. That's my original number. What if I have a whole number? So that's 5. And that is my significant digit, 5. 5 times 1 is 5. So to use the power of 10, I have to use the exponent 10 to the 0 power, because 10 to the 0 power equals 1. Based on our exponent rules, 1 is 10 to the 0 power, or 10 to the 0 power equals 1. So if I already have a digit between 1 and 9, and there is nothing else involved, 5 remains a 5 by multiplying it by 1 in the base of 10, that will be 10 to the 0. So now we can see our pattern. If you have just one number between 1 and 9, that is 1 times 10 to the 0. If you have 80s, that means, or 60s or 70s or 90s. But here we have 89 because it's 8 times 10, so that's 89. Here we have hundreds because 10 to the second power means 100, so it's 482. Here we have thousands because 10 to the third power is 1,000, so it's 7,354. Here we have 10,000 because 4 times 4 times 4 is multiplied by, 10 times 10 times 10 multiplied by itself 4 times is 20,000, so it's going to be 24,327, which is the original number. Then we see another number that has decimal. So here, this number is not in scientific notation because we have 0 point. 0 is not a number between 1 and 9. So this number is a decimal number that needs to be written in scientific notation that has a decimal behind a significant digit between 1 and 9. So that means we are going to look from left to right and find the first significant digit. That's 3. 3 is located in the tens place. That is the tens place in a decimal, first digit behind the decimal. Tens place means 1 divided by 10. 1 divided by 10 as a decimal is 1 to the negative, 10 to the negative 1. So 1/10 as a decimal is 0.1, which is 1 multiplied by 10 to the negative exponent. So here, when we have this 3, we are going to use 3 as the first significant digit and multiply it by 10 to the negative 1. 3 is a number between 1 and 9, which satisfies the form of scientific notation, which is number between 1 and 9 multiplied by 10 to an exponent. So here we have the 3, which is a number between 1 and 9. That is your significant digit, 0.2, and then multiplied by 10 to the negative 1. If I put that in a calculator, that means 3.2 divided by 10. And that is your original number from my example. So that is the same as 0.32. Let's look at another example. 0.053. So from left to right, we look for the first significant digit. Zeros are just placeholders. The significance is in the number 5. 5 is in the hundreds place. So that is the first significant digit in the scientific notation, 5. So 5, again, is in hundreds place. Hundreds place means 1 divided by 100, or 1 times 10 to the negative 2. So when we write the number in scientific notation, we're going to place the decimal after the 5, after the first significant digit, and then multiplied by 10 to the negative second power. What does that mean? That means that if I put in the calculator 5.3 and divide that by 10 twice, or divided by 100, I have the original number. So next number we have 0.007 is the first significant digit. So that is the place where we are going to use and place the decimal after. To write the number in scientific notation, we are going to look left to right for the first significant digit and place the decimal there. All the other numbers are after. Then multiply by a power of 10, which is negative, because in order to show a small number, we need to use the thousands place. So this 7 is the significant digit, which is in the thousands place. Thousands place means 1 divided by 1,000, which is in power of 10, 1 multiplied by 10 by a negative exponent. So thousands is division by 10 3 times. Division by 10 3 times can be written as a negative exponent. So this 7 is in the thousands place. It means you have to divide by 10 3 times. Next example, by looking left to right, we have the significant digit 4. 4 is going to be our number between 1 and 9, so the first significant digit. And 4 is located in tens, hundreds, thousands. That will be 10,000 place. So you have the place, the division representation. To divide by 10 4 times means multiply by 10 to the negative exponent 4. So in scientific notation, that would be 4 point, and then the other digits multiplied by a power of 10 negative. Check that. Let's see. 4 point, and then you have 465, and we want to divide that by a 10 either 4 times, or we divide that by 10,000. And that is my original number that I started with. So this is our observation, and I have the examples. On the next page, we are going to see how to go from the beginning to end to actually write the number in scientific notation.